Okay, so now what we're going to do is we're going to prove that the CYK algorithm actually works. That is, the claim we made before about xij containing all the strings that produce, all the non-terminals that produce the substring ai to aj is actually true. We're going to prove this claim here. So formally, let w be a string from ai to an, let gamma be a substring. We're going to prove that A has a derivation of gamma if and only if gamma is in the set xij. And we're going to prove this by proving it on derivation length. Okay? So, we're going to suppose that gamma is a string that has a derivation of length 1. Now, since our grammar is in CNF form, this is basically the same thing as doing induction on string length, so we can also do that. So here, gamma is a string of length 1. We're not starting from 0 because you can't produce epsilon with a CNF grammar. So the shortest thing we can produce is a character of length, is a string of length 1. So gamma is equal to ai for some I. And we have to prove this if and only if. So suppose that A has a derivation of ai. Now again, since we're in CNF, the only way a variable can directly produce a single character is if there's a production of that form, right? Because remember, what do grammars look like when they're in CNF form? All the rules have to be of one of these two cases, right? So if we're making a string of length 1, it has to be this case. So if we're going to suppose this, so A produces AI, well, this happens if and only if A is in xii, as by definition, xii is all non-terminals B, such that B can directly produce AI. So this statement's true almost immediately by the definition of xii. Okay? So now let's suppose the property is true for all strings of length n. That is, we assume the property is true for all substring gammas of length n. I'm going to prove it's true for all substrings delta of length n plus 1. So we'll assume that A has a derivation of delta. Now the only way that's possible, because there's only two possible forms A could be in, delta is not a single character, so it can't be this one. So that means that A has to go to BC, which means the only way we can derive delta from A is if delta can be broken into two substrings beta and lambda, where B has a derivation of beta, C has a derivation of lambda, and A has a production of the form BC. If this weren't the case, there would be no way to produce delta because it's the only other form A can take. Now clearly, neither beta nor lambda are empty strings because we know we can't derive epsilon in a CNF grammar. And so beta and lambda are also of length strictly less than delta, right? So in fact you have to use strong induction here, so let's change our inductive hypothesis to all strings less than or equal to n. So now we can use our inductive hypothesis to help us. Because B has a derivation of beta, that means beta must be in xik, and for the same argument, lambda must be in xk plus 1j for some splitting k, right? So whatever delta is, it's some string, somewhere we split into beta and lambda, and that place we split at is k. So beta is in some set ik, and lambda is in some set xk plus 1j. Then by the definition of xi, because there exists a splitting, we must have the case that A is in xij. And that just follows from the definition. That is, this definition here, right? Because beta is in this set, I beg your pardon, this should be B and this should be C. Because B is in this set, C is in this set, A can produce BC, and these two sets provide a splitting of delta, that means A must also be in this set. So that's proven one direction. Now we have to prove the opposite direction. So we're going to assume that A is in the set, and then try to prove A can produce delta. So for A to be in this set, what does that mean? Well, by definition, we can sort of go backwards, right? There exist two non-terminals, so A produces BC, B is in xik, C is in xk plus 1j for some k. So let's write that out. Okay, so A produces BC for some non-terminals B and C that are in these sets. Now, the distance between I and K, and the distance between K plus 1 and J, that's less than the distance between I and J, right? These sets here generate shorter substrings, so we can use our inductive hypothesis backwards. So what does that tell us? It tells us that B has a derivation of this substring, and that C has a derivation of this substring. Well, A can directly derive BC, so we can basically put these two things together and get that A provides a derivation of the entire string glued together, which by definition was equal to delta. So that means we've shown that A provides a derivation of delta if and only if A is a member of Xij, which is what we wanted to show.